In this video, we're going to continue talking about measures of center, specifically median. Median is the measure of the center of a data set, which we've already discussed that the mean is also a measure of the center of a data set. For median, what happens is the number that splits the data in half. So the median is actually where we actually split in exact half for the data set, meaning half the data values are less than the median and half the data values are greater than the median. Now, when we're discussing median, think about the median of a road. It also splits the highway in half. So the same thing happens with the data set. Now, want to look at the procedures for computing the median. And so, first thing we need to do is arrange the data values in increasing order. That means go from the smallest number to the largest number. When we do this, we are ordering the data values so that we can find that middle value. Step number 2 is to determine the number of data values, n. Recall that n means for the sample size. So how many data values are there? If n is odd, meaning we have 7, 9, 23 data values, the median is the middle number. On the other hand, if n is even, that means that the median is the average of the middle two numbers. So we're going to look at those middle two numbers, add them up and divide by 2. We're going to take their average, their mean of it. So let's look at some examples and determine the median. So when we're looking at police incidents, we're talking about the number of calls that a local police department responded to for a sample of 9 months. We want to find the median number of incidents per month. So we have this data set. The very first thing that we need to do is we need to put these in order from the smallest number to the largest number. And so we're going to go through here and write down the numbers from the smallest to the largest. Now, with small data sets, you can put them in order from the smallest to the largest fairly quickly, but if you have extremely large data sets, my suggestion is to go into Excel, and Excel will actually put them in order for you from the smallest to the largest number. And this will help you make sure that you have all of them in order. So I've got them in order from the smallest to the largest now. And now I need to find out what my n is. What is my sample size? Well, our problem up here tells us it's a sample of 9 months. So hopefully I have written down 9 values. 1, 2, 3, 4, 5, 6, 7, 8, 9, which I have. So my n is 9. Since this is odd, that means that I'm strictly looking for the middle number of this data set. Easiest thing to do is go through there and start crossing out and getting to your middle number. So in this case, the median is 671. This means that the median number of incidents per month is to which police responded is 671. Now let's look at another example. And this next example goes back to our hospital infections. This data shows the number of patients in a sample of 6 hospitals who acquired an infection while hospitalized. And we want to find the median. So we're talking about the median number of hospital infections. So the first order of business, again, is to put our data in order from the smallest number to the largest number. And again, with this small of a data set, I can put it in order fairly quickly. Larger data sets, I will need to go and look at Excel or something like that to find out what the order is. My next step is to find out what is my sample size. Well, again, our problem says we have a sample of 6 hospitals. So I'm hoping that my sample size is 6. But let's go through here and count. 1, 2, 3, 4, 5, 6. It is 6. And since it is an even number, that means I'm looking for the 2 middle numbers. I don't have a single middle number. I'm just looking for the 2 middle numbers. And so I come through here and I find out that 38 and 76 are my middle numbers. Therefore, the median is equal to 38 plus 76, and we're going to divide by 2 because we're adding 2 numbers. So my median, whenever I do that addition, is going to give me 114 divided by 2, and the median number of hospital infections for the 6 hospitals is going to be 57. Now notice there's not a 57 in here or anything like that. It's the halfway point between these 2 middle numbers. Now it is not the halfway point between the smallest and the largest, it's the halfway point for our overall data set. So don't confuse it with taking the largest number and the smallest number and dividing by 2. That just gets us a middle ground. Where we're talking about the median, it's looking at the order of the data and looking for those middle numbers. So let's look at an example. Let me scroll back over a little bit, in which we want to find the mean and the median and compare them, because we're going to find out something very interesting about this. So we're looking at the number of tornadoes that have occurred in the United States over an 8-year period. Again, my first order of business, whenever I'm looking for the mean, is to determine if it is a sample or a population. Well, this is a sample because we're talking about an 8-year period. And in the United States, there's been more than 8 years in which we have had tornadoes. So I'm going to have X bar, which is my sample mean, and I'm going to add up all the numbers. And when I'm adding these up, it doesn't really matter what order I add them. I just need to make sure that I add up all of my numbers. And so I'm going to go through here and make sure that I write down all of these numbers. And you can put this in your calculator all at once. The only thing that I suggest and tell you is that you put the entire numerator in parentheses. That goes for whenever you're finding the median as well. If you do not put it in parentheses, what happens is the calculator will just take your last number and divide it. Where in this case, we want all of them added together. And we want to divide by a total of 8 because we're talking about an 8-year period. So I get that my mean is equal to 7,230 divided by 8. So whenever I do that division, I actually get 903.75. But notice that my data values are whole numbers. Therefore, I'm going to round to 1 decimal place. So the mean number of tornadoes in the United States over this 8-year period is 903.8. Now I want to look at my median. And recall that the first step for median is putting them in order from the smallest to the largest number. And so I'm going to put these in order from the smallest number to the largest number. And then we will find what our middle number is. But we have to look at, as I'm writing these down, how many data values do I have? Because if I have an even or odd, that changes me. So when I'm looking at this, notice we divided by 8 right here. So that also means that my sample size is 8 here. So I'm looking for the two middle numbers. So I'm going to go through here and find my two middle numbers, which are 764 and 856. So my median is going to be 764 plus 856, and we divide that by 2. Now if you want to put this in your calculator all at once, that's fine. Just make sure you put parentheses around the numerator. And I'm going to continue calculating. So the median is equal to 1,620 divided by 2. So the median number of tornadoes over this 8-year period was 810. Now notice, both of these are supposed to be measures of the center. But when we look at these, the mean is actually larger than the median by a little bit. What happened was this 1,303 is not very close to most of the other data. It's an what we call an extremely high value. And so if you'll notice, the mean is affected by this extremely high value. And that's because we take into account all of the data values when we're calculating the mean, because we have to add them all up and divide. Whereas the median, if I were to change this to a 1,203, it would not affect my median at all, because it would not change the order in which they were placed. And so the median is not affected by those high values. And so that happens, this is actually called resistant. And that should be an E. And I'm completely misspelling that today, so let's try that again. So that is resistant. Resistant, where we're talking about this, is meaning that it is not affected by those extremely high or extremely low values. Therefore, median is resistant. It is not affected by one number being extremely high, one number being extremely low. This is because it strictly takes into account that very middle number. Now, mean, on the other hand, is not resistant. This can be seen, think about your grades and an instructor that takes the average or the mean. And if you get a low grade, that's going to pull your mean or your average down. Now, if you get a high grade, then that's going to pull your mean or your average up. And therefore, those extremely low, extremely high values affect the mean, whereas they do not affect the median. We can look at the histograms and also look at this. So if I look at histograms, the first histogram I have here is approximately symmetric. And the reason I say that is because we have everything here in the middle and a little bit on the sides. And so this one is going to be approximately symmetric, which we've discussed the shapes of histograms before. And so this one is approximately symmetric. What that means is that our median and our mean are here in the center, and they're approximately equal to each other. They're both going to be there in the center. There's no extremely high, no extremely low values to change it. Now, on these other two histograms, if you'll notice, and I need to extend this one out just a little bit, is that this one has some extremely high values, whereas this one has some extremely low values. So these are going to affect our mean, and our median. It also obviously affects the shape. For this first one, this one is going to be skewed to the right. And the reason it is skewed to the right is because we have that tail and that extreme value on the right-hand side. Now, your median is still always about the place of your hump in your data set. In your histogram. Because we're looking at where is the middle of those data values. Now, the mean in this case, since I have an extremely high value, that's going to pull my mean up, which indicates that the mean is generally going to be larger or greater than the median when we're talking about a skewed to the right histogram. The opposite happens with this skewed to the left histogram. Again, our median is still here where the majority of our data values are, but we have this one extremely low number that's going to bring our average or our mean down. And so here is the mean. Notice that the mean is generally going to be less than the median when we're talking about skewed to the left. So you can actually look at your calculated measures of center, mean, and median, and determine which way is my histogram going to be skewed, or is it going to be symmetric? That sort of thing. Now what I want you to do is I want you to practice some of the median, and then let me know if you have questions.